Now in this very short lesson, we're going to compare alkanes and alkenes, the similarities and the differences. We have looked at these two homologous series in detail. So if you want to, you can try on your own first. Otherwise, let's check out the similarities and differences. Alkanes and alkenes, they are both hydrocarbons, meaning they contain only carbon and hydrogen only. Okay, they have the same physical properties, meaning they have low melting point, boiling point. Melting point, boiling point increases as the size increase. They are insoluble in water, they are soluble in organic solvents. Flammability decreases as the size of the alkane or alkene increases, and then also viscosity increases as the size of the alkane or alkene increases. So they have the same physical properties. Alright, both alkenes and alkenes can undergo combustion. Actually, all organic compounds can undergo combustions, and the rules again are the same. Complete combustion, you get carbon dioxide and water. Incomplete combustion, you get carbon monoxide and water. Now there is a very slight difference between the combustion of alkanes and alkenes. That one I've mentioned before. Alkenes will give a sootier flame as compared to an alkane that has the same number of carbon atoms. Alright, and again, the reason for that is that the alkene will have a higher composition by mass of carbon as compared to alkanes. So it's harder to catch fire. You will get a sootier flame. Differences: alkanes contains only carbon-carbon single bonds. Alkenes contains carbon-carbon double bond. So as a result, we say that alkanes are saturated and alkenes are unsaturated. And because alkanes are saturated, we cannot add any more atoms to them. They can only undergo substitution reactions. Alkenes being unsaturated, we can subject alkenes to addition reactions. That means we can add some more atoms to it once we break one of the double bond in the carbon-carbon, one of the bonds in the carbon-carbon double bond. Okay, so the way to distinguish whether a solution, a liquid that we have, is an alkane or an alkene is to add bromine, either aqueous bromine, alright, which we also call bromine water, or we can add liquid bromine. Okay, so for alkenes which are unsaturated, it will undergo reaction under room conditions. So you will see that the reddish brown bromine becomes colorless. Alright, but for alkanes, you need UV light. Alright, and UV light means very strong UV light. Doesn't mean that the normal light in our room will be able to do the trick. So for alkanes, if you add bromine, there will not be any reaction. Your reddish brown solution will remain reddish brown. Now the last thing that we need to learn in this chapter is to recognize something called fats versus oil. Alright, vegetable oil has a structure that looks like this. Okay, what do you notice in the structure? Again, the structure only represents part of the entire structure, so it repeats itself to the right and to the left. Alright, what do you see in the structure of vegetable oil is this, that there are many carbon-carbon double bonds. Okay, so the term to describe this is that we say that vegetable oil is poly. Poly means more than one, remember, unsaturated. Okay, poly unsaturated because it contains many carbon-carbon double bonds. Margarine has a structure that looks like whatever that's shown. Again, it extends repeats itself to the left and the right. And what do you notice about margarine is that there are no carbon-carbon double bonds. Alright, so it's an alkane. We say that it's saturated. Okay, so in the industry we can actually make margarine by converting vegetable oil into margarine. Now how do we do that? What have we learned in the past 2 lessons that will allow us to convert vegetable oil into margarine? If you take a look at the before and after, you will notice that the difference is that the carbon-carbon double bonds, they are converted into single bonds. How do we do that? We need to add hydrogen. Okay, so essentially to convert vegetable oil to margarine, we need to subject vegetable oil to hydrogenation. Okay, what are the conditions again? You need a nickel catalyst and you need 200 degrees Celsius. Okay, so by subjecting vegetable oil actually contains many polyunsaturated molecules. By subjecting it to hydrogenation, we convert most of it to saturated molecules. Alright, so margarine contains mainly saturated hydrocarbons. That doesn't mean that it contains 100%. Margarine will still contain a small amount of polyunsaturated molecules in there. Alright, so even though margarine contains mainly saturated hydrocarbons, doesn't mean that it's not going to react with bromine. There can still be a tiny bit of molecules in there that did not get converted during hydrogenation. Alright, but in a nutshell, to convert vegetable oil to margarine, we need to react vegetable oil with hydrogen, or we need to use hydrogenation, and in the process a polyunsaturated molecule is converted into a saturated one.